Hello and Assalamualaikum warahmatullahi wabarakatuh to my panels. This video is on purpose to present my final year project 2 MEC 602 with title The Development of Automation System for Automated Tapai Machine. My name is Mohd Aiman bin Abdul Jalal and my supervisor is IR Haji Razali bin Hassan. Automated tapai machine is a machine that functions to produce continuous tapai with consistent shape and weight. Automation system will be implemented on this machine, especially in cutting process and forming process. This machine consists 3 processes, which are making process, forming process, and cutting process. Automation system. Automation technology can be defined as application use of technology, system, robots, or procedure to produce better result with limited to human interaction. The system can improve productivity, increase the quality of a product, and at the same time making a huge profitability. This machine was developed to improve traditional production, especially in tapai production. Tapai is a traditional fermented preparing of rice or other starchy food common in much of Southeast Asia, especially in Austronesian culture and part of East Asia. It applies both to the alcoholic base and to the alcoholic beverage produced from it. It has sweet or sour flavor and can be consumed as is, as ingredients for the traditional dishes or further fermented to produce rice wine. These are examples of the tapai, such as tapai pulut and tapai nasi. Problem statement. Customers and suppliers have many demands this day on product size and shape. Tapai was produced using traditional method with shaped manually by human hands without use any technology. Making tapai manually will produce inconsistent output, shape and weight of tapai because of human mistake. This technique took certain expertise as well as more time and energy to achieve good quality. This is 2 examples of inconsistent shape and weight of tapai. The objective of the project is to design forming system to achieve consistent circular or cylindrical shape of tapai food with 30 mm diameter. The second objective of the project is to design cutting system to produce consistent of each output tapai with 50 gram of weight. Methodology. The first methodology is manual method. The manual method of the forming and cutting process was done by using bar hand to find the length of tapai food that need to be cut to achieve 50 gram of tapai. There are several steps need to be accomplished to achieve the length of tapai. The first step of the method is making tapai by mixing glutinous rice, ragi and sugar. The next step is to measure 50 gram of tapai on the weighing scale to ensure the tapai with desired weight. Furthermore, the tapai was formed into the cylinder shape by using hand. Lastly, the dimension of formed tapai need to be measured using ruler to confirm the shape of the product with 30 mm diameter. The length of tapai have been measured and obtained 5 cm. Equation of linear motion. This is the equation of linear motion. From the desired length obtained, the time interval for cutting process can be calculated. The time interval have been used to cut tapai continuously to obtain 50 gram of each unit of product. Since the speed is constant, the acceleration of the conveyor is 0. And then the equation will change to S equal to S0 plus V0 times T. Programmable logic controllers were employed to control and synchronize the timing for the cutting blade and conveyor belt operation. The machine must cut the tapai at the specific spot and time to achieve the size and weight of tapai. The digital computer response time must be rapid enough to be beneficial for controlling the required speed, which varies depending on the process. The figure shows the project block diagram for automated Tapai machine. From the project block diagram, there are two inputs, which are push button and sensor. The controller used for the PLC is PLC S71200 controller, which control the motor conveyor, motor cutter, and indicator lamp. Pipe conveyor system. The main function of the pipe conveyor is to transport bulk material to one place to another place without any loss of material, as the conveyor is fully folded and trap the material from going outside. The automated Tapai machine uses the pipe conveyor system and design to form the Tapai into circular shape. The cylindrical shape output can be formed due to the flow of closed belt and hexagon supporting rollers. The pipe conveyor system requires idlers or hexagon supporting rollers as supporting rolls of the tubular shaped conveyor belt that maintain the folded belt shape. There are two arrangements of the idlers, which are inline and offset arrangement. There are different between inline arrangement and offset arrangement. Inline arrangement, it can avoid any gaps in which the belt could become entangled, and for the offset arrangement, it is more suitable for the bigger tubular shape of belt. Inline idlers mounted at the same side without any gaps will help the Tapai form uniform circular shape, with help trapping the Tapai for forming process. Therefore, the inline arrangement is more suitable for the forming process. For the belt material used for the conveyor system, there are many belt types that may be employed in the conveyor system used for the machine and the pipe conveyor system to provide the stiffness needed to sustain the tubular form, and they might differ depending on the application. Since the conveyor belt used for the food processing, the Teflon coated conveyor belt is used for the conveyor, as the characteristic of the belt provide more advantages in producing Tapai. Polytetrafluoroethylene (PTFE), or commonly known as Teflon conveyor belt, is made from high-strength woven glass fiber and Teflon coated fabric. The thickness of the belt usually is 0.35 mm. The characteristic and advantages of chosen belt. The first characteristic is provide non-stick surface, and it prevents Tapai from getting stick and stuck on the belt surface while performing forming process. The next characteristic is non-toxic, odorless, and tasteless. It prevents any change, taste, texture, color, and odor of the Tapai. The last characteristic is high tensile strength. It will last for the long period. CATIA V5 software. CATIA V5 is the software used to design and create modeling of forming and cutting system for automated Tapai machine. The parameters and dimension of the system need to be designed with accurate and precise, because forming and cutting process need to produce desired size and shape of output Tapai. The total parts per design for forming system is 7 parts, and the total part of the cutting system is 4 parts. There are several steps for modeling in CATIA V5 software. The first step is collecting data and dimension of the system need to identify and list out. The second step is sketch the design on the paper to illustrate the design of the system by referring dimension and the parameter obtained. The third step is modeling each part for both systems, and lastly, assembly the parts design. This shows the design of forming system and the design of cutting system. Calculation of resistance conveyor belt. The conveyor system consists of moving conveyor belt which provide resistance to the system. Friction is defined as the force that resists movement of one solid item from sliding or rolling over another, and the proportional of the frictional force to normal load is the coefficient of friction. The higher friction on the conveyor system, the bigger the tension for the conveyor belt. The total kinetic resistance of the machine conveyor FU have individual resistors such as main resistor FH, secondary resistor FV, and additional resistor FP. For the main resistance FH is motion frictional resistance and gravity of the material web over the length of the belt conveyor working relationship. Sum of material weight along the machine conveyor that influence the main resistance such as inconsistent produce tapai, conveyor belt, and rotating roller. The belt move on the roller and the pallet that produce two different coefficients of friction. There are three different types of rollers such as parallel roller, through supporting roller, and hexagon supporting roller. From the equation, it is used to find the main resistance of the conveyor. For the secondary resistance FV, it occurs on the non-driven drum. Resistance bearing are combined with strip bending resistance. The value of the secondary resistance is equal to the bearing resistance multiplied with the number of the pulley except driven drum at the conveyor used. The bearing used in the conveyor are the groove ball bearing and pillow block bearing. Inside the housing of the pillow block bearing is the angular contact ball bearing. This is equation to find the secondary resistance. The additional resistance FP is depending on the slope of conveyor. The resistance to overcoming the transit height might be positive, 0, or negative. Since there is no inclination or any lifting material, the additional resistance is 0 value and can be neglected. Calculation of circumferential for driving drum. Flat belt is any mechanism in which the pulley or surface only contact with the belts or cable's bottom surface. Beginning with the lesser tension force on one side, T2, which may gradually rise the second tension force, T1, to a maximum value before slipping. From the figure shows the free body diagram of unequal of the belt tension. And from the table, we can state the force ratio relationship from this equation. The circumferential force Fu exerts unequal forces on the two belt lengths, resulting in the formation of tie and a slack side, as shown at the figure. The force balance on the driven drum typically indicates that the difference between the tight side F1 and the slack side F2 corresponds to the transmitting circumferential force. For the safe and proper functioning, the peripheral drive force on the drive drum must be transmitted to the conveyor belt without slipping and with no major slack between endless rollers. The maximal frictional force indicates equal the limit of the maximum transmitted circumferential force. Therefore, the total kinetic resistance is represented as Fu max. The circumferential driving force F2 min required to keep and hold the maximum transmitted circumferential force at driving drum can be calculated by this formula. Required operating power of conveyor. The needed operating power of the drive on the belt conveyor drive drum before the slipping can be calculated by determining the value of the maximum torque that can be transmitted by the belt. Torque, also known as the moment of the force, is the tendency of the force to rotate main body by applying in physics. The required operating power that can be transmitted with the belt drive system before slipping occur can be calculated by using rotating of power. The operating power required is equivalent to the torque multiplied by the angular velocity in radians per second. Result and discussion. The first result is time interval for cutting process. The calculation requires length of the tapai to obtain the time interval for cutting process. The length of tapai measured by using ruler, which is 5 cm. The figure shows the illustration of the first cutting and the second cutting for 1 unit tapai. The time interval for cutting process is the cutting time between first and second cutting of each unit tapai with 50 grams of weight. With the speed of the conveyor is 0.033 meter per second and the length of output 0.5 meter. The time interval for cutting process obtained 1.51 second for 1 unit tapai by using equation of linear motion. Programmable logic control process flow. With the controller, the conveyor belt movement and cutting process can be specifically arranged to avoid any failure of production. The synchronization in PLC system project and timing diagram allow the tapai to be in right position and precise time while undergoes cutting process to achieve clean cut of the output. Timing diagram used to indicate interaction when a main purpose of the diagram is to reason about time. From the PLC project process and timing diagram, the machine can be started by pressing the push button. The indicator will change to green light that display the machine was operating. At the same time, conveyor 1 and conveyor 2 start moving. When the sensor 1 detects the appearance of the form tapai, the timer with 1.51 second active. The timer uses the time interval to cut 1 unit tapai calculated by equation of linear motion. Many sensors on the market currently have decent accurate and can visually accurately reflect the data observed. Thus, the cutting operator can accurately cut the tapai by the end of the timer set. The sensor 1 located in the cutting space shown in these two figures. After complete for 1.51 second, conveyor 1 stop moving and the motor cutter will be active. The function of the timer is to delay the cutting process to allow the tapai cut into 50 grams of each unit. The cutter blade rotates 360 degrees to complete one cutting process for 1 unit tapai. When the blade rotates 360 degrees, the conveyor 1 starts to move again. This process will repeat until the sensor does not detect any appearance of tapai. Lastly, the push button stop press to stop the machine process and stop the production. The indicator lamp will display the red light to show the machine is not operating. Operation process of automated tapai machine. All operation process work to produce 50 gram tapai with 30 mm diameter of cylinder shape. Each of operation process designed in CATIA V5. Automated Tapai machine consists of 3 stations, and each station have different operation of process. There are only 2 operation process need to be developed for this project, which are forming process and cutting process. The first station is making process. The function of the making process is to mix all ingredients needed to produce inconsistent shape and size tapai, such as glutinous rice, ragi yeast, and sugar. The figure shows the full assembly automated tapai machine. The second station is forming process. The function of this station is to form tapai into the circular shape with 30 mm diameter. The tapai will transfer from the making process to the forming process through the transition idlers, and then will go through the inline arrangement idlers. This station consists of 2 designs, such as design of conveyor transition idlers and idlers housing, to ensure the tapai can be formed into the desired shape and avoid the inconsistent tapai stuck while the machine undergoes the process. This station consists of conveyor idlers to avoid damaging the bed, as the transition idlers will support the bed. The figure shows the full assembly of forming process. There are 3 idlers in line arrangement for the forming process to make sure the tapai can be formed into circular shape. With the idlers, the moving tubular belt can be smoothed and prevent the belt from stuck while performing forming process. The diameter of idlers arrangement designed with 30.35 mm diameter because of the thickness of the belt is 0.35 mm, and it obtained the outcome cylinder shape of tapai with 30 mm diameter. From the figure, it shows the design of inline arrangement idlers. The conveyor belt then will be folded into tubular shape by idlers, while the tapai was formed through the tubular belt. The moving tubular shape belt forced the tapai to form a circular shape. The tubular belt is act as the mold for the forming process, with inner diameter 30.35 mm. The third station is cutting process. The function of this station is to cut from tapai into 50 grams of each unit. The formed tapai have been proceeded to the cutting process to cut the tapai into desired weight. Cutting system requires time interval of cutting blade to cut the tapai to produce 50 grams of output. The cutting section will detect the tapai by sensor, and cutter blade will rotate 360 with 800 rpm to cut the formed tapai continuously and smoothly. The cross-section area of the circular space for cutting system is slightly bigger than actual size desired of tapai because it prevents the tapai from stuck inside the circular space. The last result is the required circumferential force, torque, and operating power. The result shows the circumferential driving force, torque, and required operating power of driving drum in conveyor system before slipping occur. To prevent the operation process in the conveyor system from fail or not proper operate, the kinetic resistance of the belt need to be analyzed. The total kinetic resistance of the conveyor belt have been influencing the tension of the belt and transmitted circumferential force. Assumption mass of the inconsistent tapai produced by the automated tapai machine is 1 kg for one batch of tapai. The expected quantity for one batch is 20 units. There are 4 different friction influence the main resistance, such as pellet surface, which is coefficient of depression 0.33, parallel support roller, and transition of the through supporting roller, and hexagon supporting roller. This is the coefficient of the resistance for rollers. For the food process, the workplace need in clean, dry, or no wearing dust, as it is important to guarantee food safety. Therefore, clean, dry, and no wearing dust indoors condition is chosen for the demand resistance calculation. The mass of whole conveyor belt is 2 kg, and the mass of the belt of each resistance can be calculated according to the length of measured from figure dimension of conveyor design. The total mass of the parallel roller, hexagon supporting roller, and through supporting roller used is 2 kg, 3 kg, and 2 kg respectively. The table shows the total mass of the conveyor belt where the resistance calculated. With this parameter, the main resistance Fh can be calculated and obtain 8.2347 Newton. The secondary resistance equation requires the coefficient of friction for deep groove ball bearing, which produce 0.0015, and the angular contact bearing produce 0.002. The total mass of the roller on the deep groove for each idler set is 1.5 kg, and the mass of the angular contact bearing for non-driver drum is 2 kg. There are 5 unit deep groove ball bearing, 2 unit angular contact bearing at the lower level of the conveyor, and 1 unit angular contact bearing at the upper level of conveyor. The total mass of the conveyor belt of each bearing have been calculated and been filled in the table, and the bearing and its resistance have been calculated and filled at the table. From all the parameters measured, the total of the resistance for secondary resistor can be calculated and obtain 0.2988 Newton. The total of the kinetic resistance of the automated Tapai machine is 8.5335 Newton by sum of main and secondary resistance. With the total kinetic resistance of the conveyor belt, or we can call it as maximum transmission of circumferential force at driving drum FUMS, the circumferential driving force of the conveyor belt, which need to hold the total tension of the conveyor belt before slipping, can be calculated. The circumferential driving force which need to hold the total tension without slipping F to mean is equal to 131.59 Newton or more. With the value achieved, the circumferential force will ensure the conveyor system can run smoothly in safe and proper function. The required operating power for driving drum before slipping can be defined by calculating torque at the driving drum. The radius of the driving drum used for the conveyor is 19 mm, and the velocity for the conveyor belt is moved with speed of 0.033 meter per second. The torque of the driving drum before slipping calculated and produced 2.5002 Newton meter. The requirement of operating power for the driving drum before slipping can be defined and obtained 6.744 watt. The selection of motor conveyor can be in range from low to medium power and avoid the consuming high cost of the machine, since the required operating power is in low range. Conclusion: this project was carried out to develop an automated Tapai machine which can achieve a uniform cylindrical shape and specific desired weight of each Tapai. With the result and the methodology used for the project, the objective of the automated Tapai machine can be achieved. The advantage of this automated Tapai machine development can lead into improvement in food industry, especially traditional Tapai food industry. This machine will eliminate human interaction and save time as well as energy, as the process carried out by machine is more efficient than traditional method. This project development can be used in other food industries such as sushi production and meat packaging production, or with similar application as state. This project can be used as the future reference, or improvement can be done to this current project by adding specific function that might suit specific industry. That's all from me. Thank you.